Hello, and welcome to my presentation on management evaluation behavior. So, what is management evaluational behavior, or MEB? Primarily, it is a behavior system, not too unlike that of a behavior tree or state machine. However, there is one difference between a behavior tree and a state machine and MEB, and that one difference is in MEB, or management evaluational behavior, there isn't one defined thing you can point to and say that is currently what's executing behavior. Instead, you have a collection of things, which we call managers, and each of them influence individual aspects of the NPC, and this overall accumulatively adds together to form the behavior. This does make MEB not too different from, say, a state tree. However, a state tree cannot be multithreaded, and it also runs everything sequentially. With MEB, you can multithread it, and you don't have to run everything sequentially, which means you can optimize the order for better and faster results. But the real question is, how fast can it be? Now, the answer to that question will depend on multiple factors, such as how fast and how easy it is to access information from the blackboard. But I have made 3 AI systems, one in MEB, one and two using my university AI project, behavior tree, and state machine. But they all should functionally be the same. They all do the same thing. And I have measured the speed, and the answer to how fast it is this fast. I haven't thought about putting the exact numbers here. But generally, it is much faster than a behavior tree, especially when recursive resetting is on, which it was on for this example. It's not that much faster than a state machine, and I do reckon that depending on how you do things, you could make a state machine faster than this. In fact, I wouldn't be surprised if most of the time a state machine is faster than management evaluational behavior, unless you multi-thread management evaluational behavior. Because I did say it could be threaded, and if you do that, it is going to be significantly more faster. So you could have much more AI than you previously could, say, using a state machine. As for how much, I would say it's roughly about 2 times as much, or 3 times as much compared to that of a behavior tree, and that does seem to be what lines up here. I should get the actual numbers and put them in this PowerPoint at some point, and I'll do that sometime later. Anyways though, given that this is how fast it can be, I'm sure the next thing you're probably wondering is, how does it work? And the answer to that is, in theory, you have 3 stages: self-evaluation, peer evaluation, and execution. You also have 3 types of items: managers, scopes, and evaluational managers. Lastly, pretty much all the evaluation stages can be collapsed down into one stage, depending on how you order all the content here. But generally speaking, it is easy to represent them and visualize them and understand them as separate stages. But in terms of actually programming it, you do want to collapse them all down into one stage. It is much faster to do a bunch of checks once rather than to do a bunch of checks multiple times, or to do one check multiple times. Get the gist. So starting off with self-evaluation, in this stage we get every normal manager to evaluate themselves and determine if they think for themselves that they need to execute. If they think they don't need to execute, they stop here and they do not move down to the next stage. A good example of why this is useful is, say, a gun operating manager. If we have a gun operating manager that operates a gun, moves it to where the enemy is, and then fires it, if we have that, but say we don't actually have a gun or more or less any ammo, then there's no point in that executing, apart from to move the gun back. But if it's already holstered, there is no point in that executing. So we might as well stop it here and save it from being evaluated in other stages below, which is great. It's faster to do that than it is to allow it to move to other stages below and then block it later anyways. So we do self-evaluation. Some items will fail at this stage. Some normal managers that aren't in any scope, some managers which are in a scope, they will fail, and then they will not move down to the next stage, but everything else will. In the next stage, we do peer evaluation. Now, anything that can't go through peer evaluation, say because it doesn't have an evaluational manager in the same scope as it, will automatically move down to stage 3. But everything that does have an evaluational manager in the same scope of it will then be evaluated by that evaluational manager. And this can be done numerous amounts of ways. A good example of one way this could be done is we could use an alternate evaluation. Which is when we first evaluate the first one to go down to the next stage and block all the other ones. Then we do it for the second one and we block all the other ones. Kind of like a sequence in a behaviour tree. You do the first one, that gets to execute, then the second one gets to execute, etc, etc. It's pretty much like that, but we do skip all the ones that failed self-evaluation, which is again really good. We could do that, or we could alternatively use something like evaluate highest, which is when we get every manager to return to us a number which represents how important it thinks it is to execution. And we can do this because evaluational managers have access to all the other managers in the same scope as it. It's the only type of manager which is allowed this type of access. Other managers cannot access the managers around them. Only this one can, which is very important. What makes the evaluational manager unique. Either way we do it, any way we do it, we will eventually end up with some managers which are allowed to execute and some which are not. Most of the time we're only going to end up with one manager that's allowed to execute. That is most of the time what you'll expect. And when we're done with this, all the evaluation managers are also prevented from moving down to execution at that point. Because once they've done their job, they do not need to execute. There is no point in allowing an evaluational manager to execute. It is a pointless endeavor. So they are blocked from execution, and all the ones they decided aren't allowed to be executed are also blocked from execution and do not move down to the final stage, which is stage 3. And what we're left with in stage 3 is all the managers we want to execute. And these will cumulatively add together, resulting in the code behavior. And as for how you can multithread it, this is also pretty simple. All you have to do is make sure everything in the same highest level scope is added to the same thread. And by that I mean everything in the same scope that is of the highest level. So that's all the scopes lower than it, all the managers in the scopes lower than it. All of that has to be added to the same thread. Then we can use scopes which have nothing inside of them, and we can move that all to the same thread. And that will then be thread safe. And we can put managers after that and before that, and any manager which requires something from a manager which is being evaluated from an evaluational manager will work just fine. They will get that information without any need or risk of, say, a race condition, or without the need of a mutex. I mean, you will probably need a mutex for interaction with the blackboard, because blackboards are a thing within this system. But generally you wouldn't need it for anything more than that. You only need it for the blackboard because things outside the blackboard can also interact with the blackboard. Like eye sensors, they can report back things that are seen to the blackboard. You will need a mutex for that if you don't want a race condition. But in general, that is pretty much how it all works. It's very simple to understand, but there is some level of ordering to things. You do want to make sure that some things are in a certain order for some evaluations, which is something you have to keep an eye out for. But yeah, now with that done, I'm going to now show you some videos of AIs I have made with this. I'm going to show you two AIs. One is going to be an AI that is basically an extraction shooter AI, and the other is going to be the AI I used that is made to be like the AIs I've created for my AI university project. And yeah, so I'm back now, and I'm now in Unity. First AI I'm going to show you is the extraction shooter AI. It's very simple. We have these AIs. They are extraction shooter AIs, and they are also made in Unity. Now, I should mention, I did say it can be multi-threaded, but Unity does not like you multi-threading things. It is very much against that, and if you try to multi-thread something that either interacts with a game object or some sort of background Unity system like the navigation system, it will not be happy with you and it will not work. So these are not threaded, but for reference, you can add a threaded one. It's just got to be a threaded one which does nothing to the game object. And as you can see, it is there. So it can be done, and it does work, just as long as it doesn't interact with the game object. Which does kind of make it a bit pointless for Unity, but in other game engines, this will not be pointless. It will be very helpful. We also got our behaviour set, and I believe that's this one. In this set, we got a lot of things, and it's all kind of hard to understand. But don't worry, I'll walk you through it. So the first set of things up here are the death managers. These managers manage basically killing the AI, because it has to be done in a certain way. We don't want the AI to move after it's dead, and I don't want to bother making a component for it. So I did this. This manager actually kills the AI if its health is dropped below a certain amount. This manager makes the AI die if it failed to extract in time. So the next thing we got is our aggression system. This makes the AI more aggressive or less aggressive. This is then used by other parts of the system because it's not multi-threaded, we don't have to worry about that, to determine if we should act aggressively or not. And most of the time we don't want to act aggressively. Acting aggressively could equally get us as much killed as it could get the one we're acting aggressively towards killed. So if we can avoid it, we don't want to act aggressively. Although if they spot us, we might want to act aggressively just based on fear response, or if we haven't got enough resources, we might want to act aggressively just to try and get the resources we need, which is what all this does. This resets aggression back to its default state, and as you can notice, this is in a scope. Everything inside a scope usually gets executed linearly. That's not always the case. Like I said, there are moments where you will want to reorder things, but generally that's for things involving evaluation. There is no evaluation or logic here. There is below, but not here. So here, everything's executed in order. First thing we do is we set aggression, then we run this check, and this check. And based off these checks, we decide how aggressive and if we want to be aggressive. But most of the time it's just storing a bool that represents if we're in an aggressive state or not. So below is where we have our first evaluator and our first evaluational scope. You know how I said we can have things that execute before and after? This is where we do that. We have things that can be executed after evaluation and before. And this again comes in very useful for movement. We can have a bunch of movement managers, all which plan a path to different parts, and then we can evaluate them and only get one of them, and we can feed that into actual movement, which is what this does. They all report one value to the blackboard, but only one of them gets to execute, and that value is then retrieved for actually making us move. Also, this manager comes with the behavior system for Unity. These managers do not, which is why they're called user managers, and this one's called MEBM. In case you wondered why the difference was there. But here we have two evaluators. One is evaluate highest. It gets all the managers to return a number, which represents its own importance. Like I said, we could do that. And then the second one is evaluate block. This determines if we're acting aggressively. If we're acting aggressively, we also want to be able to move aggressively, which is why it blocks get close if we're not acting aggressively. Likewise, if we are, it doesn't block it. That's what this does, by the way, that it blocks a part of the thing from executing or not. And like I said, we can have multiple evaluators. Just gotta make sure that no evaluator can evaluate another evaluational manager. But this system takes care of that automatically. It just filters them out of the scope for you, which is pretty nice. All you have to do is just add them, it sorts it out. But yeah, we got that. The first manager here makes it wander to a unique point. The second manager makes it go to the extract point, if it should go to the extract point, which is basically if we got enough resources, or if we're running out of time, etc. etc. Second manager, third manager is the go to resource point. Basically, go to a thing we need to up our resource count, and our resource count is basically if we got the amount of items for resource count, or does it required resource count, we're good. If we haven't, we need to get more resources. Get item, meanwhile, moves us to the nearest health or ammo object if we're low on health or ammo. And flee makes us flee from the current target. The reason why this is not two different managers, one for getting health and one for getting ammo, is because that's how I also did it in the University AI project. I made it so that this was just one behavior state for behavior tree in that. So I kept it here and made it one individual state, and then I reused it for this because I added health and ammo. So this is one manager which you'll find in both types of AI, as well as wander, which is a nice little fact, and flee, and get close. But that's why this is for getting health and ammo, and not just getting health or getting ammo. And then last but not least, we have this, which runs after evaluation, and basically only one of these things is selected in evaluation, and based off that, we walk to that one thing that was selected. And we also have some stuff for operating a gun here. It's all fairly standard stuff, to be honest. It's just all organized in lists, which can make it a bit hard to navigate, if I'm being honest. But this system I made in Unity is pretty much just only an example system. A real system would probably have names at the top of individual parts, and maybe the list will be on a graph instead of in one gigantic list with list below list and so on and so forth. Anyhow, now that I showed you this AI, let's actually show it you in action. And while we're at it, I'll do that as well, so you can see it work in real time. This doesn't normally happen. I'll pause this and get back to you when it's done. Okay, it's done. And now we can see our evaluation managers. Now, this tick here means that this made it to execution. That doesn't necessarily mean it's doing anything. And these aren't. But with this, we can see right now it's only moving to a unique wandering spot, and now it's moving to a resource. So we can see what the AI is currently moving towards, what its current goal is, and we can also see what it's doing down here. This is just for making sure everything in the blackboard is up to date involving the gun. It's not particularly special, but we can see it's currently making the eye follow the path, which means it's not being shot at, because otherwise it'd be trying to fire the gun or reload the gun. And through this we can infer data like that. Has it died? It's just been unselected. But yeah. Also, these yellow lines are just from the gunfire, just so that I could see it working, in case you're wondering. Anyways, now that you saw the AI, let me just show you them all fighting, I guess. As you can see, they go to resources. They like resources. Resources are good. And when they've done collecting enough resources, they get to leave. Some of them will collect enough resources without getting involved in a fight ever, others will not. These two got involved in a fight, and now they're both running away because presumably they both haven't got enough health. Or ammo. Ammo in this case. I'm pretty sure it just picks them up. Oh yeah, by the way, when that sparkle effect goes off, that means it just reloaded. Oh, you're not doing so well. And you could do with more ammo. Surprised none of them have died yet. Normally they do tend to die. No, it's not dead. It's just thinking. They don't stall when they're thinking, it's just the trait of the wandering system. Sometimes it takes a while to find a path. Oh, someone's died. This has died. And some of them are actually extracting. Nice. These are the extract points, in case you're wondering what those were. He's just reloading his gun, isn't he? Yeah. Has he done it? Oh, he's nowhere near done. I imagine he's playing aggressively then. That's why he keeps running low on ammo. Because his resource count is so high. He just wants to shoot everyone to get their resources. And I'm guessing, yeah, he's forgot about the guy behind him. I made it so that they forget after a while. I'm guessing that's what happened with our friend here. You're just camping out on the resource spot. Another one's completed their mission. Oh, he failed. That can happen. Sometimes they do fail to complete their mission. If the resource counter is too high, or if they just strike unlucky and they can't find area with enough resources. But generally, most of them do tend to complete their mission or die. Which is nice. Because we want them to complete their mission. And if they die, well, it's sad, but it means less resources to go around. Oh, 5 of them failed. Anyone else left? Dead AI. I'll go up some more. Yeah, it did. It went up by 2. I guess 2 people stayed out to try and get even more, just to finish it off for the last old Mary. That's nice. And that's not even programmed, that's emergent behaviour of the system, because of how it works. Sometimes other things will override some things, just because they can get that and go there, which is a benefit of the system. It can multitask, can do multiple things at once, which is really nice. Again, it can be threaded. Most behavior systems can't, but this can. It's specifically designed so that it can be threaded, which does need to some nice behavior sometimes. Still, better than failing, which is the least desired outcome, if you believe it or not. So it's not a problem. Let's run it again, just because I like saying it. And then I'll show you the other AI. Well, these 2 are going to have a fight. Yeah. That guy wasn't happy about that other guy stealing his resource. He's still going after the resources. I mean, I guess you have priorities. Oh, did he die? No, he's just reloading. Is he hogging a spot to get more resources? Yeah. Some of them died really quick. Last one, they didn't die so quickly. A lot more of them had died as well. Whew. I guess the random distribution is unfair this one. They're all fighting each other to the death. It's really unfair this one. That's just outside its vision cone, isn't it? Yeah. Alright, no, it was getting the ammo first. It needed ammo. In case it got into another fight. I imagine. Damn, a lot of them are dying off. He's going to extract. Because he held that spot. Nice. Oh, you're dead. My condolences. I imagine these two are dead as well. They look dead. Oh, no, he's still alive. That one's dead. He's got the stars on him. Oh. Unlucky. He's not going to make it there. Yeah, I would go for the ammo as well so you can shoot him back. Did he die? No. Is he hogging a spot? I think he's hogging a spot. Yeah, he's hogging a spot. I believe the hogging of the spot happens because they can't find a point in a sphere nearby. Because that's what the wandering AI is supposed to do. It's supposed to find points in the sphere. But sometimes it fails because Unity is not very helpful at all the time. Which is very annoying, but hey, I could increase the minimum amount of checks it does before it gives up. That's something to look into. Are you going to extract? Oh, you are. And so are you. Is that because you failed? I think that's because they failed. Yeah. Any other AI still alive? Oh, we got one. He's still chasing the resources. Oh, he doesn't know where an extract point is. That's why he's still going after the resources. He could die if he's not fast enough. Oh, he's got so many! I feel like moving them closer to where a resource point is. Because their wandering system usually makes it so that they wander in a way that's completely unique. But I'm guessing this guy was just getting so much health and ammo that he didn't stop to look around. Oh, he is going to an exit now. Good on you, you drink good for everyone. He got 288. My man, he's mad. Most of them get something like 60. That guy got 288. He's bringing down the medal. I don't think there's anyone else left alive. I don't see anyone else left alive. No one in the buildings, is there? Nah. Nah. Oh, that guy's dead. No. But that's the extraction AI. Now to move on to the other one. Alright, no, that's... Yeah, there we go. So in this scene we have two AIs. Their only objective is to fight each other and kill, and to find each other if they can't fight, because they don't know where each other are. This is the AI set for that. We're using just eval highest here, not using multiple evaluators. It is pretty basic. And we got all these different path planning systems, one for fleeing, getting items, getting close, and then wandering for if we can't find our target AI. We also got the gun blackboard interface, as you're pretty sure you expected. Then our regular stuff for operating a gun, reloading it, firing it, making the eye follow the path if there is no need to operate the gun. The reason why it's called make eye follow path is the gun and the eye are the same thing. That's this thing. This is the gun and it's the eye as well. Ta-da. But we got pretty much all that. There's nothing else, no extract logic, it's just this. And it is pretty basic. And as I'm sure you can imagine, they do find each other pretty quickly. But when they flee away from each other, then they can forget about each other and then try to find each other again, which is pretty nice. Oh, he's out of ammo. These fights can go on pretty long. That is the point. They don't want to die, but they do want to kill each other. So it could take a while. What are you trying to do? He's caught between fleeing and attacking. I know why. It's because he's thinking, oh, I have enough health, I can attack. And I should have enough ammo. And then he runs out of ammo instantly after firing the first shot. And then he's just like, okay, now I'm fleeing. That is something, that is just a flaw I am responsible for. That's not a flaw with how this behavior system works. I just need to weight some certain things better. Oh, now he's wandering around. And I'm pretty sure this is using the old wandering node as well, isn't it? Yeah. So this could go on for a while. I should have programmed these AIs better. Even if it was meant so that they were similar to the university AI ones. I should have programmed them better. I'm wondering when one of them will die. I think the other AIs are better, even though the extract AIs are better, even though they share a lot of the same logic with this. They use a better wandering system, so it does always explore new places. It's not constantly walking back on itself. Should have put that in this instead. Anyways, I won't show you anymore. I'll just leave it at that. I'm sure you get the gist. They fight each other, they kill each other. It's not programmed well because I wanted it to be like the other AIs I made. I mean, not to say that the other ones I made are good, but they're not for 3D, they're for 2D, and they have a faster moving speed. So this isn't an issue for them. It is an issue for this one, though. It doesn't have a faster moving speed. But, yeah, that is the crux to bear. Actually, I could make it better while I'm here. There you go. That won't actually affect the managers in this game right now, but it will be better. Provided, of course, it saved that value. Yeah. Anyways, that's all the AIs I made. Next time I'll know to actually test these in game before just doing a speed test on them and calling it a day. And yeah, that's pretty much it. Goodbye. I love this thing. Which button?